Today we are learning squares and square roots. This video will tell you everything you want to know about square and square roots. We'll start with the basic, which is the square of the number. So square of the number is the number generated after multiplying a value by itself. For example, if somebody asks you what is 4 square, that means 4 needs to be multiplied by itself. So 4 into 4 becomes 16. So 4 square is 16. The same way, the square root. The square root is the value which on getting multiplied by itself gives the original value. For example, if somebody asks you what is the square root for 25, which is 5. That means if you multiply 5 and 5, you will get the answer is 25. Hence, root of 25 is 5. Into the second part, which is the table of squares from 1 to 30. This is a very important table because these are the squares that is rarely common everywhere. So you need to remember the square of these numbers in order to make your calculations a little faster. The next which we have is the square root table. So basically this table has right now the square root till 20, but you can learn more also as you progress. But the major ones which doesn't have a decimal is the major one you need to remember. So square root of 16 becomes 4, square root of 25 becomes 5, square root of 36 becomes 6. So once you practice all of these things and when you start using all of these things, it will become easier for you. The next important part which we have right now is the properties. This is really important for you to solve the calculations a little faster. So the first property says the square number can only end with these digits, which is very obvious if you think about it, because if I have 1 square, the last digit is 1. If you know about 9 square, last digit is 81. So if you look at all these squares, you will get it that the last digit of all of them is basically these digits only. You can look at the table also which we have done in the previous slide, and you can go through as well and see all here. The last digit is 1, 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 here is also 1 and 1. If you look at this 4 everywhere. Correct? Now if you look at it carefully, there is no number which has the last digit as 8. The square of the number, none of the square number has the last digit as 8. So if, for example, any number is there whose last digit is 8, it is not a square of any number. So for example, if I say 28, 28 is not a square of any number because the last digit is 8. To give you a little easier, these properties will help you make it a little easier for you. Okay. Coming back to the rest of the properties which we have. The second property says that the number of zeros at the end of a perfect square is always even, which is also obvious because if I do 10 square, so that means 10 gets multiplied with itself. So obviously 10 to 10 will become 100. So this will have 2 zeros. If I do 100 square, which is 100 into 100, this also will have how much zeros? 2 and 2, which is again 4 zeros, which is even number. So you will always get in even numbers of zeros in a perfect square. Okay, coming to the next part, what is the square of even numbers will always be even. So when you have to find the square of even number, it will always be even. Square of odd numbers will always be odd. You can obviously take an example and see. For example, we have 9 square as 81. 9 is an odd number, 81 is also an odd number. Then we have 10 square. 10 square is 100. 10 is also an even number, 100 is also an even number. So you can always take an example and prove these properties. The fourth one, it says if a number ends with 1 or 9, then its square will always end in 1. Again, the same obvious wala thing, because if you look at 1 square, which is 1, if you look at 9 square, it is 81. So obviously if the number ends with 1 or 9, it will always be 1 at the end, because 1 into 1 is 1 and 9 into 9 is 81. Hence always it will become 1. You can always check it using the other number as well. For example, if I do 19 square, so I have 19 into 19, which will become 361. That means the last digit will always be 1. Why? Because if you add unit and unit digit, so 9 to 9 will always give me 81. Hence the last digit will always be 1. Okay. Similarly, exactly the same thing which we will do in the fifth part also. If my number ends in 4 or 6, the square will end in 6. You can take any example if you want. We have 4 square, 16. We have 6 square, 36. Last digit, 6 and 6. Hence, every time if we use any number, the square will have the same number of unit digit. For example, if I do 24 into 24, 24 square becomes 576. The unit place will always be a 6. Because why? The unit place has 4 and 4. So 4 into 4 becomes 6. Right? Perfect. You can always take an example and see in case you have any particular doubt. Coming to the next property, the square of 1 is always 1 and the square of 0 is 0. It's a very important question. It sometimes comes in MCQs or in assertion and reasoning questions. The last is the square of positive number or the negative number is always positive. Positive number will always become positive. Why? Because if I have plus 7 into plus 7, plus and plus will always give me a plus. So hence it becomes plus 49. If I do minus 7 into minus 7, again minus and minus will give me a plus, which is plus 49. Because plus plus is also plus, minus minus is also plus. Hence, the square will always be a positive number. Coming to the next. Then we have a perfect square. We already spoke about what a perfect square is, but just giving a small overview. A perfect square is a number which is the square of a particular number. For example, if I say 4 square is 16. 16 becomes a perfect square because it's the square of any number. 36 becomes a perfect square. Why? Because the square of any number, which is 6 ka square. 25 becomes a perfect square because it is the square of any number. If we talk about 19, 19 is not a perfect square. So this is what the term perfect square is. Great. We'll go ahead and start about the next topic. The next topic is finding square roots. If you're talking about finding square roots, we have two major important topics, which is prime factorization and long division. We'll learn about each method in the next slide. Then we have prime factorization, the first and the very important and commonly used method. This method basically people use it when you have not so big number, like for a small numbers, when the quantity is not that huge. For example, if I have to find out the square root of 1764. So what will you do first is you will do the prime factorization, which I'm very sure that you guys have learned in the previous grade as well. But I'm going to put it out. So 1764, the smallest prime number is 2. So I'm going to divide with 2 because the last digit is 4. I know it will be divisible by 2. Then if I divide it, it will become 882. 882 will also be divisible by 2 because the last digit is 2. So again it becomes 2. Then it becomes 441. Now because the last digit is 1, this will not be divisible by 2. The divisibility rule of 2 says if the unit digit is 0, 2, 4, 6 and 8, then only the number will be divisible by 2. Hence I'll try the next digit, which becomes 3. The next prime number is 3. So I'll apply the divisibility rule of 3, which says if you do the sum of all the digits of the number, that should be divisible by 3. That means 4 plus 4 is 8, 8 plus 1 is 9. 9 is divisible by 3, hence 441 is also be divisible by 3. Hence I'll divide by 3 and then it will become 147. 147 again because last digit is 7, it will not be divisible by 2. Then I'll start divisibility by 3. Again I'll check 1 plus 4 plus 7 is how much? 12. 12 is divisible by 3. Yes, hence this number will also be divisible by 3. So I do this, this becomes 49. So now by practice I know 49 is the square of 7 and 7. So basically this becomes the prime factorization. Once you do the prime factorization, I will always suggest that you write it in the horizontal form. because it's easier for you to make the groups there. So then it becomes 2 into 2. If you write it 2 into 2, 3 into 3, and 7 into 7. So it becomes a group of 2 because you're finding out the squares. You will take 1 2 from this group, 1 3 from this group, and 1 7 from this group. So it becomes 2 into 3 into 7. Hence it will become 42. Okay. So the square root of 1764 becomes 42. On to the next method, which is called the long division method. This method is used when we have a larger numbers, because then the prime factorization will be huge. Or when will you use this? When you have a decimal numbers. For example, if somebody asks you find out the square root for example, 13.625. How will you do that? Using long division method. The first and the most important step for this long division is the putting up the bars. How will you do that? Whenever a number comes, for example, if it's 4768, you will start from the right hand side and make a bar of 2 2. So this becomes 1 and this becomes 2. That means this becomes one group and this becomes the other group. Okay. Now, for example, when the decimal value comes in. When decimal value comes in, what will you do? For example, I have 267.142. In decimals value, that before decimal, it's normal number, like it's a whole number. This may, they will do the same thing. You'll start from the right hand side. So 2 bar, like above two numbers, we have 1 bar. And because 2 doesn't have anything above it, anything like what do you say, front of it. So that's why I'm going to put up a bar here. And after that, we have the other side of the decimal. Other side of the decimal means you have to put the bar this way. The other side, from left to right. Hence, the bar will be on 14 and on 2. This will help you solve the long division. I'll take another example. The example which is given here, which is 13.625000. So before decimal, it's right to left, and after decimal, it is left to right. So this becomes a bar on 13. This becomes a bar on 62, 50, and 00. So first step for long division will always be you putting up the bar. Now let's take one example without the decimal, and then we'll take an example with decimal. So I have a square. You have to find a long division for 4489. First step is to put a bar. So I'll start from the right hand side. I'll put a bar on 89 and on 44. Now my next step is to look at which square of the number is nearest to 44. I know that 6 and 6 is 36, which is near 44. Because 7 and 7 will be 49, which will be greater than 44. Hence, we cannot put it in the division part. Hence, I have written 36. So, 44 minus 36 will become 8. Then I bring this 89 down. Correct? So, now what will we do is, we're going to add these two numbers. So, this is 6 and 6. So, it becomes 12. Okay. So, now I have to put one digit here and one digit here. Both the digits have to be same. Okay. And I need to check, is it possible? Like in some cases, it will be possible that you get 889. In some cases, it will not be possible. I'm going to give it a try because it says 9 at last. So I can do it as 123 into 3. So if I do that, this becomes 3 3s are 9, 3 2s are 6 and becomes 369, which is a very small number. Then I'm going to try a different number. So which is, again, the last is 9. So I'm just trying 9 right now. So I'll try 127 into 7, which becomes 49. So 7 2s are, this will become 889. So hence I got the number, I'll put 7 and 7. Hence the answer is 67. So the square root of 4489 is 67. Okay, that's how you do long division. Now, in this particular case, how we have done this way, you can do the exactly same thing using a decimal value. In the decimal value also, we do the same thing. The first in this case is a decimal value. So we're going to put up a bar. Before the decimal, it is this side, and after decimal, it is this side. Hence, here it is only 2, so the bar is on 2. Here it is 56, so bar is on 56. We'll always take the bar numbers together. So first is 2. So the nearest square is 1. So 1 square, which is 1 into 1 is 1. And I subtract it, it will become 1. Now I will add these two. So 1 plus 1 will become 2. I will take 56 down, and then it is 6 and 6, which will become 26 into 6. I will multiply this and I get the answer as 156. Hence it will become 26 into 6, 156. Hence the square root of 2.56 will becomes 1.6. It's easier for you when you do long division for decimals value. It gives you the accurate answer and it is a little faster as well. We have the next question. Find the square root of 42.25 by the long division method. I will suggest to put up the answers in the comment section and let's see who get the answer correct. Good. Next we come to the next part where you do estimating the square roots. What happens in estimating the square roots is it gives you an approx value. I know you can find out using the values of prime factorization, or you can also do it by long division, but sometimes you need to be very quick. So this type of things, estimation will give you a quick answer. It is good for when you do it orally or verbally if you needed the faster answer. What will you do is, for example, somebody asks you what is the square root of 20. So what will you do is you will clearly think about which is the square root that comes just intact with 20. So I know that which is 16 because it's 4 ka square, and then it is 25 because it is 5 square. So I know the difference between 16 and 20 is 4. The difference between 20 and 25 is 5. So obviously this square of this number will be nearest to 4 because it is nearest to 16. So hence it will become 4 point something, or you can put it as approximately root of 20 is 4.5 or 4.3. It's going to be just an approximate value. It's an estimation value that will be near to 4 instead of 5. Great. Now the next kind of question which is very common and it comes in a lot of exams where it talks about find the square root of 5 correct to 2 decimal places. Whenever they're asking you to find out through 2 decimal places, that means you need to do it for 3 decimal places, because what will you do is for the third place that comes in, you're going to round it off. Okay, I will tell you how will we do that in the later stage. First, how will we do the long division? Because we need 3 decimal places, hence we need 3 bars after the decimal. So that's why when we're putting up 5, we are putting 3 bars. So hence there are 6 zeros that comes in. Okay, and now you will solve it exactly the same way. Let's start. So we're going to put up the bars first. So 5 is alone, so I'm going to put up a 5 bar and 5, and then there's 0, 0, 0 and 0. We'll start from 2. So it's 2 2s are 4, and then 1 comes below. Then I'm taking the 0, 0 below. I will add 4 and 4, 2 plus 2, and then it become 4. Correct? Then I have to put up a value here and here which is same. Now I'll try 42 into 2 is giving me 84. If I try 43 into 3, it will give me a bigger number than 100 because 4 into 3 becomes 12. So it is saying 129, which is obviously a bigger number. Then what will I do? I will try the next thing which is 84. Hence I got 16. Then I'm going to put a 0, 0 down. Now in this case, how will you do the left part is you will take everything which is above it, which is 42, and the new number you added. So 42 plus 2 becomes 44. Correct? Now again you have to think about what digit you will add here and here, which has to be same, and it has to be a little less than 1600. So we have tried it out and it comes out to be 3. So 143 into 3 will become 1329. 0 down. Now in this step also we do the same thing. We have 443 and the new number that we added is 3. So 443 plus 3 will become 446. Okay. Now we'll add 6 and 6 and it will become 26796. And below the remainder is 304. It will go on because again It is an irrational number and root 5 will go on. But in the question, they're asking you to only find it correct to 2 decimal places. Hence, we find already for 2.236, which is correct to 3 decimal places. Now we look at the last digit, which is 6. Now you're going to round it off. How do we round it off? We look at the digit. Now this digit should be either, if it is 5 or more than 5, the number will be, the digit before this will be added to 1. If it is less than 5, the number remains the same. Okay, so in this case, it is 2.236. The digit is 6. Hence, it is more than 5. If it is more than 5, the 3 becomes plus 1. So, the answer will be 2.24. Okay, if you can't understand my handwriting, let me know. I will put it on the comment as well. Okay, this is a very important question. It usually comes in. So, make sure that you practice this. We are done with everything you need to know about squares and square roots. In case you have any questions, feel free to put it on the comment section. Thank you.